For your response. For question A, you are asked to find the tangential velocity vectors in the instance shown in the graph. So how you would find the velocity vectors is by one, a vector is only one, it can only be shown by one arrow, and where I messed up was I drew plenty more than one arrow, that's for sure. So if I did end up drawing one of the correct arrows, but a vector is only one arrow. So the correct arrows were going for A to the southwest, and then for B going straight up north. Both of these vectors are perpendicular to the acceleration vectors, which are the ones that are like given as shown. Question C. You are asked to find the acceleration vectors. And so in this same one, I purposefully did more than one arrow, and where I should have just drawn one arrow. Anyways, the acceleration vector is the vector that is pulling it, or that is being pushed around the entire circle. So that's why the acceleration vector is straight back towards the middle, because in a tangential circle as shown, your acceleration is going to be caused because of the force that it's being pulled in a tether-like motion. Question E on the graphs. So I got 1 point on this graph because I started my line above 0 in the horizontal velocity x squared column. The reasons I didn't get the other 2 points was one, it didn't stay above the positive x-axis, and then also it was moving around, whereas it should have been a solid straight line. So how this is supposed to work is just like one of the multiple choice questions. The horizontal velocity will stay the same time, or stay at the same constant speed throughout the entire free fall. Question F. So on this one, you are asked to describe the vertical velocity, and so the vertical velocity on this one should be a constant, just like one of the other multiple choice questions. This one is going to be a straight up constant, or a linear function that goes straight down starting at x equals 0. It starts at 0 because when it gets off the table, it's starting at nothing, which is also 0. From then, it has a constant speed of falling down all the way till it hits the ground, and when it hits the ground, then it flatlines again, but it's just asking for when the object is in a free fall, which is why it is a constant speed in a downward direction. Yes.